You've kind of had this happen to you. You ask an AI a question, and you get back this answer that sounds so incredibly detailed, so authoritative, and it's just completely, totally wrong. It's a really weird and sometimes kind of creepy phenomenon, and it turns out it's not just some random glitch. Today, we're going to unpack why your favorite AI tools are basically designed to lie with confidence. Let's kick things off with an example that shows just how bizarre this can get.
So to really see what I mean, let's look at a simple little experiment that some researchers ran. They decided to ask an AI a pretty straightforward question about one of its own creators, a guy named Adam Kalai, who's a senior scientist over at Microsoft Research. The question couldn't have been simpler. When is his birthday?
And the AI didn't even blink. It just shot back with a super specific date, April 9th, and it said it with the same absolute certainty it would use to tell you the sky is blue. I mean, it sounds totally plausible, right? But then, just to see what would happen, the researchers asked the exact same question again. And this time, you know what it said? October 26th. A completely different answer, but again, delivered with 100% confidence, like that first answer never even happened. And here's the kicker. Neither of those dates is his real birthday. Not even close. The AI just made them up. It wasn't confused. It wasn't making a simple mistake. It was actively fabricating, and it did it without a single shred of doubt.
So this is what the folks in the industry call an AI hallucination. And that word confident is the key. It's not just an error. In fact, a lot of academics actually prefer to use words like confabulation or fabrication, because those words really capture the idea that the AI is literally building a false reality from scratch.
Okay, so your first thought here is probably the exact same one I had. This has got to be a bug, right? Or, maybe the AI was just trained on some sketchy data from a weird corner of the internet. These seem like the obvious culprits for any tech problem. And look, all of those are really intuitive explanations. It just feels like there must be some bad code somewhere, or that if we just fed it better, cleaner data, we could just stamp out these kinds of mistakes. It's a totally logical assumption, but it also happens to be completely wrong. The real truth is so much deeper, and honestly, it's a little bit shocking. We've been thinking about this whole problem in the wrong way, because the answer isn't hiding in the code, and it's not in the data either.
What if this tendency to just make things up isn't a flaw we can patch, but it's actually a core, unfixable feature of how these systems are built?
Well, that's exactly what some groundbreaking research from OpenAI has proven. Hallucinations aren't an engineering problem that we can solve. They are a mathematical inevitability. It's literally baked into the DNA of how these large language models work.
And here's the part that really blows my mind. Even if you could give an AI perfectly clean, totally comprehensive, 100% factually accurate training data, it would still hallucinate. The problem isn't the stuff it's learning from, it's the fundamental math it's built on.
So if it's not bad data, why on earth does this happen? Why is an AI mathematically programmed to just invent answers? Well, it all comes down to some really twisted incentives baked into its core design.
Researchers point to three huge mathematical issues. First, specific facts are actually pretty rare in all that training data, so the AI doesn't have a strong statistical reason to believe them. Second, the AI structure itself just isn't complex enough to hold all of human knowledge perfectly. And third, some problems are just unsolvable. They're mathematically proven to be impossible, so no algorithm can ever get them right every single time.
But there's another piece to this puzzle, and it's a problem we actually created ourselves. The very way we test and grade these AIs has accidentally trained them to be confident liars. It's something called the evaluation trap. Think about it like this. In most of our standard tests, if an AI is honest and says, "I don't know," it gets 0 points. If it takes a wild guess and gets it wrong, it also gets 0 points. But if it guesses and just happens to get it right, it gets a point. The math here is brutal. There is absolutely zero incentive to ever admit you don't know something. The best strategy every single time is to just guess. So, how does this all play out in the real world? Well, let's look at another test. This one is almost comically simple. A state-of-the-art model was asked a basic question. How many letter Ds are in the word DeepSeek?
Now, you'd think this would be a total slam dunk, but in 4 separate tries, the model confidently answered 2, then 4, then 7, and then 3. Every single time it was absolutely sure of its answer, totally inconsistent, and completely wrong.
The correct answer, of course, is 1.
There's just one D. This really shows that the problem isn't about the AI not knowing complex things. It's a deep, fundamental flaw in how it's built.
So, if we can't get rid of hallucinations, then what are we supposed to do? How do we build and use these ridiculously powerful tools without getting burned? The whole focus has to shift from trying to eliminate the problem to trying to manage it.
And there are some really smart strategies out there for this. We can use techniques like RAG, which is kind of like giving the AI an open book test where it can only use pre-approved sources. We can force it to show its work using something called chain of thought reasoning. We can even use human feedback to basically reward it for telling the truth, not just for guessing. And of course, there's the simple, old-school method of just double-checking its answers with other models.
But, and this is probably the most important thing to understand, none of these is a magic bullet. They can make hallucinations happen way less often and make them less severe when they do, but they cannot get around those fundamental mathematical limits. The risk is always going to be there, even if it's a small one.
And this leads us to the single biggest takeaway for the future of AI. The goal can't be to build some perfect, all-knowing oracle that's going to replace human thinking. Instead, we have to start seeing these tools for what they really are, incredibly powerful assistants that are designed to augment our own judgment.
And that leaves us with the real challenge. It's not about fixing the AI, it's about changing how we work. Knowing that these tools are fundamentally flawed, how do we build the right workflows, the right habits, and just a healthy amount of skepticism to use them safely and effectively? That's the question we all need to start asking ourselves.